Okay, in this video, we're going to look at compound gears and gear ratios. So what we have here is a compound gear that has been assembled with simple gear trains. And we have 4 simple gear trains combined. We have 1, 2, 3, and 4 to form this compound gear system. So when we talk about gears, we have to talk about their ratios. And when we calculate a gear ratio, we're taking the number of teeth on the output gear and dividing it by the number of teeth on the input gear. So in this assembly, we have our first set of gears that have an 84:12 ratio. That means that this gear, this larger gear, has 84 teeth, this smaller gear has 12 teeth. And we reduce the fraction, we end up with a 7:1 ratio. So for every 7 turns on this small gear, this large gear will turn 1 time. So what happens is this gear will then turn slower and you'll get more torque. But let's say that's not enough torque. Let's say we need more power and a slower speed. We start to combine these gears to form a compound gear. We end up with more gears and thus more ratios to work with. And so the way a compound gear works is it takes that gear ratio and it multiplies as it goes down the line. So we would take these 2 gear ratios, and we're using all the same gears here, this small one and this large one. We have the same ones back here, we can't see. And so each one of these separate gear ratios is 7:1. But if we multiply 7 times 7 and 1 times 1 between these 2 separate gears, we end up with a ratio of 49:1. So every 49 turns that this gear does, this gear will turn once. And if we combine and multiply 49 times 7, we end up with a gear ratio of 343:1. So every 1 turn of this gear will have to turn 343 turns. And finally, when we get down to this last gear, the gear ratio will be 2,401 because we've multiplied 343 times 7, and that gives us this number. So when we turn this mechanism, we can see those gear ratios working because this first gear is going to turn pretty fast. It's turning slower than this gear because remember that this gear is going to turn 7 times for every time this one turns once. And for every 49 turns of this gear will turn once. This gear will have to turn 343 times for this gear to turn once. And then finally, at the very end, that gear that doesn't look like it's moving at all, this gear has to turn 2,401 times for this gear to turn once. So every time we add these gears together, we're multiplying the number before it by 7. So we can continue to make this gear ratio higher and higher as we go down. And of course, we can use different size gears to get different gear ratios. They do not all need to be equally sized. Okay, so we can use different numbers, different teeth, and we can get different gear ratios by simply doing multiplication across each of the simple gear trains.